Hello, statistics student. This video is for chapter 2.7, part 3. We continue the discussion on standard deviation, which is the main measure of variation. So when we have a list of data values, we know how we can use the one variable statistic calculator or StatDist to find range, standard deviation, and IQR, or primarily standard deviation. Now, if I have a table which is summarized, so these are data value that I don't know, but someone published it that say so some great values, right? 50 to 59, there's one data, don't know what number it is. 70 to 79, there's two data. But what is the standard deviation? If I want to estimate the standard deviation by using this grouped data, of course, it would not be the same as the real one. But if I want to estimate it, how do I do it? So what you do is you use the um, LibreText GFDT group frequency distribution table mean and SD calculator. So we talk about this when we in the mean section 2.5 section, but we'll just review how to do this again if I'm going to do standard deviation. So to do that, we assume that the data is actually the middle of the class. So you want to find the midpoint of 50 to 50.9. So what you do is you add the two number, the upper and lower limits, and you divide it by 2. So that would be 54.5. And the second one would be 60 plus 69, and you do divide it by 2. So that's 64.5, etc., etc. So I should have 74.5. Well, actually, this one I don't need because it's 0, so I don't need to do this. Then I have 84.5. You can just write it out. 94.5. How do I know it's 10 away? Because the class width is 10, right? So the class width is 10. So the midpoint should be 10 away from each other. So what I'll do is I'll use this LibreText GFDT mean calculator. Use a browser. I think I have it here open already. So it's under LibreText and it's called mean and standard deviation for group frequency table calculator. I clear things that I have before, and I'm going to do the midpoint. Enter the midpoint, which is 54.5. 64 I don't enter because there's nothing, right? There's 0 frequency. 84.5, 94.5. Yeah, I think I only have 4 number, right? And the frequency is 1245. So the frequency below it is 1, 2, 1, 2, tab, 4, tab, oopsie, 2, 4, 5. And these are, they don't say anything. I think they are sample and you don't need to do anything. You just do calculate. Oh, but the calculate is at the bottom. So you do it and the mean is 84.5. The standard deviation is 12.1. Okay, I want to round to 1 decimal places. So I calculate all the class midpoint. I put it here and I enter it. So it's 12.06, 12, round to 12.1. So that's how you do it. Other measures of variation, so other than range, IQR, and standard deviation, there's two measure that you need to be aware. One is the population standard deviation. We seldom need to calculate it because often we don't know it and we use S to estimate it. But the important things to know that there's a symbol for population standard deviation is called sigma. Now, and it's written as like this, which is a Greek letter, right? And just like mu so anytime we have population parameter, we tend to use Greek letters. So population standard deviation is sigma. Okay, and the formula for it is the reason why I didn't talk about it when we talk about sample standard deviation is a different formula. The way you do it is you have all the population data, you minus the mean. The mean is the same. You square it, you add them together. These are all the same, but you don't divide by n minus 1. You divide by the total number of data n. You take square root. So this is the formula for population standard deviation. There is calculator that can calculate population standard deviation, and I'm sure that you are aware that when you use the one variable statistic calculator, they often has the population or sample, right? So why they worry about having you to specify it? Because the formulas are different. So if your data is your whole target group's data, and it is so the standard deviation you're calculating is not sample, you would have to click this. Okay, so this is what you click. Otherwise, by default, sample standard deviation is click. Okay, so the other measure that we want to go over is called variance. There's two variance: population variance, which is sigma square. That means the formula is whatever that you have before without the square root. So if I want to do sigma squares, what is the variance? It's actually all the difference with the mean, square them and divide it by n. Okay, you can say it is the sum of square with the mean divided by n. And then what about sample variance? So it is before you take square root, so sigma x minus x bar square divided by n minus 1. So before you do the square root. So they don't have their own symbol. They just use the symbol for standard deviation. And for variance, population variance is sigma square. For sample variance is s square. So you can tell that actually standard deviation is the square root of variance, or the variance is the square of the standard deviation. Why do we need to introduce it? We don't use it to compare variation, but they're used in statistical analysis. The behavior of of s squared is very special that we can actually analyze it. Okay. And by analyzing it, we can also analyze standard deviation. So how do I find population variance and standard deviation? Of course, this is the one, right? You use the one variable statistic calculator from LibreText, paste the data if they are in commas, and then remember to click population standard deviation. So say, for example, I assume that these are all my target population. So I calculate it. You can see that the standard deviation change. I think it was 0.7, now it's 0.69. So I can change it back, okay? If I calculate, see, it's 0.7. So these two number change. And if you manually square 0.7159, you'll see it is 0.5125. The variance is actually the square of standard deviation. So do an example. So I have some age data again, and I want to find the population standard deviation. So I can calculate by um, doing this way in list form. So that's good. I clear the old data that I have, paste it in, and then I have to click population standard deviation and calculate. You can see that the standard deviation is 3.8, the variance is 14.76, which is 14.8 also. This is called a variance. This would assume that this is the whole class that you have. The class has 10 students, so this is the population of a study, then you would calculate standard deviation that way. Okay. The way you analyze data is the same. Most data are within 2 standard deviation from the mean. Let's look at the next things we want to look at is how to understand the use of standard deviations. So standard deviation, it measure how data are spread out or how they are varies, right? So if I am measuring a diameter of a bottle cap, so a factory use a machine to manufacture a bottle cap, and it's used to, um, don't draw really well. So to put it in the top here to screw, or is the cap of a soda or a drink or whatever, mineral water drink. So you put it in. And if you are manufacturing these, of course, you want it to be as precise as possible, right? So when it is precise, that means they always have to have the same diameter, but that's not possible even with machines. Sometimes it varies. So what do you think you want your measurement would be? I would think you would want your measurement to have very low standard deviation. That means less varies, right? It'll be horrible if your bottle cap sometimes is large, sometimes it's small. So the factory would want to monitor the output so that the standard deviation is low. Uh, the third example is also about analyzing standard deviation from a histogram. So instead of calculating the standard deviation, sometimes we can look at a histogram to see which has a high standard deviation. So look at the first one. This is diameter of bottle caps from two production line. They all center around, I don't have axis, I don't label the axis here, but I assume that they all center around 50, right? So that is supposedly the size of the bottle caps that you're supposed to make. Now, if it varies so much, it's a very bad it's a very bad example, I think. Um, so I think we are assuming these are the same, uh, you know, uh, uh, x-axis. Maybe, the axes are here, so it is, it's in the top. I don't know why. So 50, 60, so it's the same range, but these are more, cluster around in the middle, so they are less varied, right? So don't be fooled by the fact that, oh, they have high frequency that they must be very, very. No, frequency means most of the data center around this number. They're less vary. These are more varies because why? They are more spread out, and there are a lot of data that are actually very far away from the mean. So this would have higher standard deviation. So we didn't calculate it, but this will be a higher SD, this will be a lower SD. And so if you see a graph of the bottle cap coming out, you want this to be very skinny histogram. So I'm going to stop here, and then in the next video, we're going to talk about relative standing and Z-score.